Alright, so let's get started because we haven't had class in, feels like 2 weeks. It's been about, it feels like almost 2 weeks. I know I only missed one Monday, but when it's once a week, it's hard. I thought I would come back to basics today for the Objective-C part. We'll do some fun stuff, but like about halfway through, we'll switch and do a TextView kind of thing and look at some Objective-C code in action. But I sort of want to revisit the concepts here because I have a lot of interesting questions that I've had people ask, and I've been wondering, I wonder how much of the basics are actually enforced here. So just to reiterate the point of the object, we do have this object. Everything we're doing, even if it's iOS development, is in the form of creating objects. If you're not creating objects in the program, you're not really doing object-oriented programming. Instead, actually, it's impossible. It's impossible. You even have a view controller object. You have an app delegate object. And you have a view object, whether you like it or not. So it's really impossible not to have those objects. And then the concept is you're adding more objects to the classes. And as you're doing that, you're creating classes. And you're creating things that are going to be, other types of objects that you're going to be adding in. So what we're looking at is the concept of the object. The object has these methods. It's kind of an interesting looking object here. The states are the data that's being held. So in our interface file, we're putting in those states. Those are the data that we're declaring and we're holding for the object. And think of it sort of like the core, which is why I kind of like this picture. And then the methods are surrounding it. So this is why the internal state is protected by the methods, so we have all of these as private data members. In fact, you can't have any public data. It's all private in Objective-C. I mean, you can, but in theory, if you're going to follow object orientation correct, you're going to make those private. And then these are all public methods, so they're the protecting mechanism. And so what you end up having here is we got two objects here that are communicating back and forth. So we have one object that via a method sends a message to another object, which is why they call them messages sometimes, and then that method turns around and sends a reply back. So as we've been creating objects, we started out with the pencil to begin with, and we took a pencil and we made different types of pencils, if you remember. This was about 5 or 6 weeks ago, actually, the beginning, first day or so of the class. And then we had the pencils doing stuff, and they weren't really communicating very much. They were kind of, we were running stuff to make the pencils do stuff. But now we can have objects that make other objects do stuff, which is sort of the focus of this kind of second section of this course, the intermediate levels. Now, instead of just one object living by itself, we're going to have multiple objects. We're going to see it, if you're in the iOS course, we're going to see it today as well with more hands-on stuff. But basically, one object making an instance of the other object and then telling that other object to do something and then destroying the instance or making another instance and sending the instances to other objects to have them do stuff and work together to accomplish a task. And it's really just the kind of modular breakdown of how you're going to design practically every object-oriented program. And it applies towards any language as well. So what does Objective-C give us? What does it even look like? Well, we know what it looks like. We know that we have these header files. This is just a major review as well. We have these header files. Hopefully you get that point down. We have the implementation files. The implementation files are private, actually, just to note that. These are public interface files, which is interesting. It's the same as in other languages. When we include something, we include the public interface, which is this here, and then the implementation is that private part. And we know that we've got that header file concept. So this is the part that people after you create a couple classes and then well, I want to implement the class, then you get that part down. Well, I need to include, and the template already sets it up for you. So if you created my new class or here my image.h, my image.h isn't going to have anything in it, but my image.m is going to have my image.h at the top. It's going to be included in. And then a lot of the Mac code will have the Coca library. Older code will. This is an older lecture. And you also see Foundation as a core library as well. Depends upon what type of development you're doing. And then you're going to have Coca Touch. So Coca is basically the language for the Mac OS X. The Coca Touch is your iOS kind of platform. And then your Foundation is everything It's really just the foundation of Coca. So there's a couple different variations there, but just again reiterate the point, just because we're kind of regrouping today after a couple weeks. We've seen this before, and we're hopefully familiar with this concept already of the interface and the implementation. It's very important in this particular case to separate them out into two separate files. This file here is the .h file. And we know that this is the core data. This is private. We don't actually have to use the words public or private. This will be private by default. And we put the data in between the opening and the closing brackets. Another reason why I'm reiterating this is I got a couple messages over the last couple weeks, people trying to do the assignments, and I'm looking at code samples they're showing me, and I'm going, well, whoa. You know, they put the methods in here too, because that's how you do it in C++. That's how you do it in Java. So just know that the core of that object, if you think back of that picture, the little white center, that's in an island of its own. It's not part of the rest of the public interface. So that's what goes inside of those opening and closing brackets. This is the white section of that object. And in here we have a couple different things. We actually have a two-dimensional array. That might look familiar if you're familiar with C or C++ and you've looked at arrays. And then we also have this up here, which is, and this is done kind of on purpose to show you sort of the difference, as I mentioned before. We can put C code in here. We can't put, well, we actually could put C++ code in here too, because Xcode recognizes it. But we can put legacy kind of C, non-object-oriented code, just the same way as you can write C code in C++, you can write C code in Objective-C as well. But we're looking at this and just reiterating the point as well. This is a pointer. So all of anything that's an object in the language will always be referenced by a reference pointer. And I can say the word reference and I can say the word pointer, and people don't normally get it until they see the asterisk if they're familiar with C++. And then they go, oh yeah, it's a pointer. It means the same thing actually as it does in C++. So this is our NS string. We can do NS integer, we can do NS anything we want. And actually NS, just to, in the beginning of this here, I kind of skipped through it. In the beginning there's an NS explanation for those people who missed the beginning of the course and are just just trying to pay attention at this point forward. NS is from the history of Next Step, by the way. Just a little piece of trivia for you. Originally designed in 1980 as the fusion of Smalltalk. Well, NS is really Objective-C is really Smalltalk and C combined into one. Popularized by Next Step. That's the name of the company, actually, 1998. This is where we get the NS from. And then Apple bought Next. Well, Next Step with Next. And then in 1996 acquired an operating system along with Steve Jobs. So that's basically where the NS is standing. And they left it in there. I'm sorry?
NIB.
Yeah, that's where that came from as well. Yep, that's where it came from. And then here's our little, kind of timeline. Around 1996 or so is when it turned into what we're basically still using a dialect of today. So, yep. Interface builder. Well, they started XIB now for Xcode interface builder, I think, instead of nibs. So, but you still hear nibs around, actually. You still hear the word being used. So, a refresher on that concept there. What do we got here? So going back to here, we have our @ symbol, our @ directive for those guys who haven't been paying attention so far. Basically saying we're talking to the compiler. This is going to be the interface we're defining. We're defining it as my image, and we're using, this is actually the same syntax as C++. This says we're inheriting from, but instead of using public, private, protected, and those access modifiers and stuff, we don't need to do that in Objective-C. But this would be the equivalent to putting a colon in here and saying public NS object, because it is public. So, and then this is where we're inheriting from. So when we bring a class in, we have seen it so far with NS objects, with UI view controllers, with UI tab controllers. It's basically all the basic core functionality that we're extending. We're going to see it perhaps today with a tab controller example. We're going to build part 1 of a tab controller. And then it depends on how long we think depends on how long you guys think the tic-tac-toe game is going to take for the iOS class. I don't want to rush through that one, so we'll see. But we'll be building one today that is going to be working with a tab view controller as well. And so just to continue on here, we know that we have the minus signs, means it's an instance method, not a, if it was a plus, then it would be a class method. Same as the instance and the class methods we get in C++. That's our initializer. We went through initializers already in this class, so refresh your memory on that just so you know. Because what ends up happening is I spend a lot of time cutting and pasting and putting code in, and then people, all of a sudden start forgetting, what is the syntax we're using. So it does help occasionally to go back and kind of review a little bit. We know we put the data types inside of opening and closing brackets like this, which is interesting. Instead of just saying, like, in a particular case here, void set name, we actually put all of the data. In fact, everywhere you see a data type, it's always inside of those opening and closing brackets, which is kind of interesting. We know we've seen ID before. It's a generic data type. It's equivalent to the asterisk or the pointer in C++. Actually, it's equivalent to the same concept here as well. So in this particular code, we're running an initializer, and we know it's an initializer because it has init in it with name, and we know that it's going to take on one parameter, name. And name's going to be an NS string data type. And we know because we have the colon here, we could take on two or more, as we see down here, where we say a character, get pixel at X, and then we're going to take on here one variable, and then we're going to take on another one, and we're going to call it Y. So we have an X and a Y. And so we know that we can name the variables when we put it in. So if you remember that part, we've gone over that already as well. And then we have here just a string name, which is going to be a getter. Excuse me, yeah, a get method actually. And this is prior to the synthesize and the property concept, as we've seen. And so a lot of people, they start using their synthesize and then the property and the synthesize together, and then you realize, oh, then you forget, yeah, one of these days are worth concept of accessors and modifiers, or setters and getters. So that's what you're looking at here. So you're looking at one set here of setters and getters because we're not working with an object. We can do a property and a synthesize on an object and have that work automatically for us. And what that does is it just, I'm sorry? Yes, you may. That's great. And then if you do that, what you end up having then is the automatic synthesized, which are going to be the setters and the getters created for you. In this particular case, we've got, looks like it's going to be just a regular old set pixel value, and the pixel value is a regular old variable. It's not an object. So you kind of sort of see the contrast between the two methods. This, by the way, is optional. We don't necessarily have to put that in, because we may not necessarily need to retrieve. If we're just going to retrieve the name, we don't necessarily need to get the name. We don't necessarily have to write a method, so it's optional. Here's where we're going to have one that sets the name to name. We don't need that either, actually. If it's just taking the name, we can actually set it automatically as well. And then we have the at end that goes at the end. So in Xcode, sometimes, actually all the time now, when you create a default project, in the implementation file, you also get the header file that shows up. Why they have it header file twice, I always delete it. But you could put them both in one file, or you can add stuff in the header file and not put stuff in the implementation if you wanted to, or I don't know, use them both. So what we're looking at here is just a little bit more explanation in terms of the data types, which is coming from Coca. So if you import the Coca library, so you can use the Coca classes, these are the Coca classes. Anything that starts out with NS traditionally comes from the Coca library. But the funny thing is this foundation includes Coca. So it's just another library that you can use. So a lot of people will just see foundation, and they'll see Coca and Coca Touch in there as well. And it depends actually on what kind of class you're creating in terms of if, when you go in and the Coca Touch or the Coca, it'll give you different included libraries and the project types, and the Xcode will do that for you automatically. Here we're always going to come from an NS object from Coca. Our view controllers, our other objects, our protocols or categories, and some might actually not. They might not come from object, they might come from view controllers or something of that nature. So you create a new class here called myImage, and myImage is a subclass of NSObject, which is the subclass part. And then here we have our definition. This is just basically going through the parts I was overviewing for you a few minutes ago. Here's the instance variables. So we put the instance variables inside of the opening and closing brackets. And then down here we're declaring the methods for the image class. So it's the declaration or the function prototypes that are going in the .h file. Don't try to implement everything in the .h. So. Now in the implementation, or this is our declaration here actually, in the implementation we're going to put the bodies of all of these, and it has to match identically, if you remember that part as well. So when we declare it, we're looking at this format here with the data type with the name and then the two variables or the two parameters that we're going to use. So the character here is the return type of the method, as we've noticed from other languages. In other words, the type of expression object. In fact, here's the syntax for running it actually. The object get pixel at x colon x, x colon y is going to, excuse me, y colon y is going to return a character, which is going to be the data type for object that's going to come out of that. And just refresh your memory, this is also the syntax for running the method. We don't use a dot notation like we do in C++. Although you can use the dot notation, it does work in some circumstances. So the name of the method is also called its selector. So that's another term you'll hear in a lot of tutorials and things. The selector method, the selector for the method. And also it's named parameters in this particular case. That y is a named parameter. So that confuses some people as well. It's a feature from Smalltalk. So actually, I don't know if it really does improve readability, but you know what it does? When you start running iOS applications and you start looking at running methods, and then you're winging, oh, it's in it with, you know, name, and then you're going, oh, name, you know, it kind of helps you for readability. It kind of helps you figure out, well, what parameters are needed here? So we see that. And then here is the parameter variables with their types. We have an integer and integer in there. So just remember, all of the types are always enclosed by opening and closing brackets. And here's our implementation file. And in the implementation file, as I was mentioning before, we're importing our image, myimage.h. And then at the implementation, which is where we're saying myimage. Now, I've had actually some people who try to inherit at this point. You don't actually have to inherit. Once you've done your interface, and when we have that, the interface that is showing the inheritance, then we're just implementing at this point because we don't necessarily have to mention that all over again. In fact, all we have to do is include the .h file, and then we know we're coming from NSObject or from UIViewController or from wherever we might be coming from. And then here we don't have any data repeated. We do have the at implementation and then the at end at the end of it. But in here what we're looking at is just the implementation of the methods. So a lot of people say, well, why in the world do you want to do this? It's a lot of work, separate it out like that. Well, the thing is, this is going to turn into an object. The .m is the implementation, the h is the interface, and it's a protective mechanism, actually. You're making it so that you're not giving away the object every time you want to include it in a file or a project. Because it's going to sit in a little directory somewhere, and it's going to be linked in dynamically when you go ahead and go compile something. So it never gets recompiled. So think of it more like a contract in order to reuse that object over and over again. That .h file is going to give you that sort of interface, public interface to it. So you don't have to actually ever have to look at the code again. And that actually leads to the concept of encapsulation in the language. So here's the set pixel implementation, and we're going to throw an NS exception here, and we're going to raise the invalid range exception. So we can actually do, well, that's one of the things we get in Objective-C that we don't have in C++ or in C, actually, is this automatic exception handling that we can put. It's more of a Java, actually, kind of feature at this point. And the format is going to come back and say the pixel location is outside the image range, meaning you wrote past the bounds of the 16 by 16 two-dimensional array. And then if not, then make it equal to the value that we're given. And we'll put that number in there. And then all the other methods that might be down here. So the importing the header file here, knowing where you're implementing or knowing what you're implementing. And then the name. So it tells Objective-C we're defining the methods for myImage. And then the definition, as I mentioned before, defining the methods outside. Defining the methods, not outside, but inside of the .m file for the implementation of this. And all you basically have to be concerned with is that make sure that matches. If you leave it out, believe it or not, you'd think it would be an error message. Believe it or not, it's a warning. Which is kind of interesting. So pay attention to warnings that you see. It means you've got like, maybe an unimplemented method. You've defined it, but you haven't implemented it. Which maybe you're not using it yet, and you want to test before you're done with the project. So, but it's interesting that that's a warning and not necessarily an error. So here we have our object space method, which is the way we're sending a message to the object. And this is the receiver object. This is the message that's going to be sent via the method. So if we send a couple methods here, we have integer age1 is going to be equal to the person age, and then person father age. So we're going to get the father's age and return the age from the person object father instead of just person. So, which is for age number 2 that we're going to get out of that. So we can nest messages inside of messages, send one message, and then the remainder gets sent the other message that comes through it. And then arrays here for the array add object to the object, and then array insert object at index 0, which is interesting. You can't really do that in C++ either, unless you do a for loop for it. So the built-in methods for the array structure, well, this is an object. So in C++, it's not treated as an object unless you create a dynamic array or some sort of a linked list structure or something, and then treat it like that. And then have insert and delete methods and things of that nature. In Objective-C, we actually get that as a standard object implementation with methods. So we can say, you know, at index 0, put in this particular object, insert this object into the array. And a little bit on the super and the self, which we've been seeing in a lot of source code examples, but so it merits a little bit of explanation. So the self is the reference to the current object, as we mentioned before. So we say if we want to run a method that's inside of our, in fact we'll see it with the tic-tac-toe game actually, self space reset the board, meaning run this method inside of us because we're the one who wants it. So normally we would send messages to other people, but if we want our button to do something, we would ask self to do it. Also things, for example, in the viewDidLoad method, we can run self a lot to say, hey self, load this website into this web view. Take this image and take it over there and prepare things up in the viewDidLoad. So here we have a method for a time interval for the age, and we're going to return, and then we're going to get an instance of date from NSDate. So we're going to return a date. Now some of this code is missing from the implementation. We're just showing you syntax here. Time interval since the date. We actually saw this when we built the timer a couple weeks back. And then send a self birthday or something, you know, just as a way of recognizing that. And then super allows access to the super classes methods. And so we can return super age plus 60. We want to, as an example. And what super was going to be NS object if we're inheriting from object. In this particular case, it's probably person going from another person to another person. Maybe it's a person and then it's an employee, then it's a boss or it's a supervisor, or maybe one object created another object in that particular case. We have a hierarchy going on, and a super is going to go back up the chain. So our class methods, we saw class methods actually with the categories, I believe, or we actually saw it with the protocols. What does it mean? Well, we saw it with both. Different implementations of it, and with different reasons. The plus sign over here, normally we see a minus. The plus sign is basically going to indicate that it's a class method. Well, received by the class itself instead of instances of the class. So in the implementation of the class, you're going to use this method. So in some cases when we made the interfaces, we made the protocols, we used them sort of like interfaces in Java, actually. It's equivalent to that. We implemented methods like print as an example in the particular object, and because we included this interface, this protocol, it was mandatory that we implemented it. Well, it's really a class that's implementing another class's method. When we run it, we can run it on the if it's a class, we're going to run it on the class. We're never going to really run it on an instance, but we can use it for functionality. We saw this with adding things to the NSString class. The reverse string example, took and created a class method that was reverse string so that we can include this particular category into our project and then run the method when we needed that functionality. It supplemented the NSString and it built from that hierarchy. So it comes in handy. Anything that's not associated with an instance is going to be at the class level. So here's an example. Here is a test to see if something is a subclass. So how are you going to test that? Well, you can do it out in, I was going to say main, but we don't really have a main. Well, we do have a main, but out in an iOS application, you can do it out in any object. You can say, is this a subclass of this class? Which means, are we in the same hierarchy? Because then if we are, we could do something to it. And if we aren't, then we know not to. So the class methods are called on a class itself. So if this one has a plus symbol, this one's built in for us, by the way, is subclass of class. We can say NSButton is subclass of class NSControl class. This is what we did with those UI buttons, actually. Actually, it was called introspect. What we did is this is why I'm going over this lecture, because we went over all the fun stuff, but we didn't hit the basic concepts that we were actually going over. So we'll backtrack a little bit and say that, if you're out there and you're in a controller and you're looking at the view and you're trying to see, let's make all the buttons disabled. Then all you have to do is test to see if all of the buttons are of a particular subclass, or of the components, that you have out there. Are they all buttons? Are they all part of this? Are they containers? What are they? And then disable them all as a group, instead of having to go to each one of them individually. So that example we did actually took all of the labels and changed the background color on them, changed the text. So basically working as a group and looking at them in terms of the object type, and this is the method we used actually. We used the class method for is a subclass of a class, and we're not running it from an instance, we're running it from the class itself that we're including. And this is on an NS button that we're running, and we're going to run it to see if it's part of the control class. And it is part of the NS control class, so come back yes. We've been looking at variables. And I've been talking about objects, and we know that there's a difference. We also have the concept of the variable, and we're going to see that today when we look at our tic-tac-toe game. But we're going to make an object and use it as a variable. We could say integer I, but we're going to use NSInteger instead because it's Objective-C. But variables are declared just like in C. So I have an integer I is equal to 0, we have J and float, and then we have the NS string. And then we have that one equal. And we're used to this @ symbol, I hope, at this point as well. It's the compiler directive just saying, I'm defining a string. Here's a string. Why don't you just leave that out? I don't know. They want to put that in there to confuse people, I guess. But just remember, anytime you want to tell the compiler that you're giving it a string, you're giving it a number, you're giving it something, here's an implementation, here's a interface, you have to use the @ symbol. Objects are always pointers. So objects are always pointers. Usually you're never going to have a case in which you're trying to use a non-object as a pointer, because people just run from that anyway and they don't like pointers. So just know that after you initialize it and create it, you use it just like anything else. It's just an object. So instead of the C string, Coca uses this NS string as well, which is equivalent to the C string, which is equivalent to the string and string.h from C++, which contains the unit text code. We know that we have that dynamic type. That dynamic type is the generic type called ID. It's used when we don't want to commit ourselves to any other type. And we have this statically typed concept, which is kind of interesting. This is dynamically typed. This is statically typed. You're wondering, what do we mean by that? This one can change, that one can't change. Okay, but I still didn't answer the question. This one's bound at compile time. This one's bound at runtime. Oh, what does binding mean? Well, it means we've allocated the space for it. Alright, so long story short, a lot of people will use ID when they don't necessarily want to allocate any space. Why do you want to allocate space if you don't even know what you're going to use yet? So in the old days, people said, oh, integer this, float that, make this array, make all that stuff, right? But just non-objects, just right. That takes up a lot of memory, makes your program run slow. So you can use ID to make your program run a lot faster, especially when you don't know, like it's going to be like a 300 megabyte video file, and you're gonna allocate that right now. Are you gonna allocate 100 of those? No. Probably not, but you got some audio, you got some video, you got some PDFs, and you got some content that you're going to try and display and use somehow in your app. We'll make them all IDs, and then load them up and allocate them and change the type And it's better for, well, not only for the memory management system, but it's also for the dynamic behavior of it. You haven't just loaded every single thing up and you're only going to call one at a time. So you're going to load them a little bit more efficiently, makes your program run faster, long story short. You're not going to see that unless you're working with something with really a lot of memory. Most people in a small Hello World program are never going to notice anything with it. But that is the difference between the dynamic and the static. It's just this is delayed. It's delayed binding, delayed allocation completely. This one, if you made it, you made it. We're going to have a my dog. We're going to have it whether we like it or not. It's always going to be stuck with that and it can't change. So, we just create a lot of them then. So it uses dynamic binding. The method names are not resolved until runtime, actually. We have nil. Nil's used a lot. It's kind of like null, but different. Nil is the nothing objects. Everything is initialized to nil, which is great because you don't get that in C++. You make a pointer in C++ and then you ask the pointer, you go reference the pointer, dereference it, you get garbage. Here you'll just get nil. It's nothing. So you can check for nil. If person is equal to nil, it means you created the reference to the person, but you haven't assigned anything yet. It's still nothing. So here, if it is equal to 0, if it is equal to nil, then age is equal to 0, and name is equal to nil. And eat taco fails silently. Person eat taco. Well, all right. I think that was a joke, but long story short, method doesn't work. Some methods take nil as a don't care parameter associated with it. Yeah, that's a don't care parameter. We have the Boolean data type in this language as well, just to refresh your memory on that one. It's developed before C99, so when C gained the Boolean type. So we have objective C. It does have the Boolean type. And a C++ is a true. We have a yes, we have a true, we have a 1, and we have a true. It depends on what are we going to get back. Because in every language we have slightly differences between what's considered on and what's considered off, or true or false. So we get a yes that comes back, so we check for yes. C gives us a true. Actual value is 1, so we could check for 1 or 0 actually. C++ true or false. We can also use the true or false capital. So in our class here, classes are almost like any other object. And this is the interesting part that takes, well, once you start working with it, it doesn't take too long to get composed with the concept that your NS string is the same as your person object, which is the same as your dog object or whatever it is that you're creating. And use them all the same way. And so what you're doing is you're just supplementing the base language with your own objects, and then you're inheriting from existing objects. So class type is a class. There's no pointer associated with it. So class myClass is equal to myClass class. And then myClass class method, run a class method, which is basically giving us our basic syntax for how to run objects for the class. And if some object is a kind of this class, then the object is a myClass, which is how we're testing it. So we have the reference to the object, and then we have the object itself that's being called, to instantiate itself. And then we have those selectors, as we mentioned before, including all the colons that are part of it. So select fetch selector is going to be equal to selector fetch selector. So we actually use @selector to get the selector, which is our parameter list that we're gonna get out of that. So it includes the colon, and it's equivalent to this here. Fetch at. Actually, you can use the syntax, by the way, as well. You can use the keyword class as an object reference of a type that you're actually going to create. So we've seen, well, we'd have to allocate if we're going to do something with that, but yes. So it's equivalent to this one here, but you can see you can store selectors or SELs here, and then pass them around and use them as generic selectors. So you can even call an NS selector from string, NS string, a selector name, or anything you want actually. So you can call it from fetch, from @selector, get the selector. So we have the delegates in terms of the construction that we've been looking at so far, and the selectors that are used in Coca. The delegates are duck typing. often referred, actually it's called duck typing, sometimes they call it that. Object response to selector, and the selector comes back. So we have the target action pattern that we're mostly familiar with using. So the button set target to self. So we see this automatically when we go ahead and we drag and drop, and I call it wiring. We're setting the selector, and the selector in this particular case is going to be set up here, using in the generic form of the object. And it's really the same format for everything that we're wiring or we're tying from an interface to a regular object. We can do this outside of just the interface builder and outside of just wiring up those components. We can create the targets manually. So here's the action pattern here, where we see button set action at selector, button pressed, or something. And then this is the format that we're looking at that we take for granted because we do it automatically and we see it happening and we go, oh, and what does that mean? Well, the target is itself and it's looking for an event, and we're usually seeing an IB action actually in this particular case. But we can actually set the button actor, the action this way as well using the selector. So our foundations, our life as an object, we allocate, we initialize, and then we deallocate. Well, now we just use automatic reference counting. We just allocate, allocate, never deallocate. So the life of the object, and we've seen this before, we have to alloc, and then we have to init. So most people do it together. So if you're not going to alloc and init, you can, in fact, one is an alloc is a class level method we're running on it, which is interesting because everything is allocated and it's allocated at the class level. We can't allocate an instance by using an instance, so it's at a class level. And then to initialize it is always an instance level because we're running the initializer that's inside of each one of the objects that we've created, which if you missed the first part of the course, don't know an initializer, it's similar to a constructor, but it does the same functionality. It's just called an initializer. We can also put in what they call convenience constructors, so we can have constructors and initializers. So a constructor is just basically assigning data to the data members of the object, and they're used special purpose only used once or twice to do something like that with. So here we have the syntax that we've seen so far. To refresh your memory again, I know it's been a couple weeks, but now we're back up to speed here. So my class, my instance of my class alloc init. Just if you have to memorize anything, here it is. When you allocate it, you have this black hole. When you initialize it, now you've got something in it. This is the universe, I guess, inside of the black hole. So as the analogy goes, yeah, this is not a bad thing to remember, I should say. And for those people who are taking the IT students who are taking this class, who are taking the final exam, I'm probably gonna have you like write stuff like this out there. You know, like initialize an object called initialize an instance called my instance for an object my class. Allocate it and initialize it. So hopefully you'll be able to recall how to do it. No, this is lecture number 6, by the way, I'm going through. So, and we have our life of the object here where we have a deallocate. Well, I'm never going to see that. Well, we might see that, actually. And for another trivia thing, actually, as well, sometimes you see legacy code that's not using automatic reference counting. You can actually take the object, the C class, the objective C class, change its attributes to take off the automatic reference counting. Because sometimes there was instances in which we allocated, and we want to retain, and we don't want to deallocate. And the program logic is working with a retain rather than using an automatic reference counting. And then the automatic reference counting, if we modify the code to take out all the retains, take out all the releases, take out all the deallocates, and just allocate, we don't get the same functionality. We don't get the same behavior because we go back to look for something and it's been garbage collected. It's been taken out for us automatically when we really wanted to retain it. So most people find that when they can't retain when they want to retain, then you just take and you go up into the property of the class itself, and in the center window I can show you. Actually, I think we have a project later on that we're going to do that with. And you just change the property to put back. It's a switch that you're putting on the compiler that says don't automatic reference count this particular class. Leave this class alone. So half your project is using ARC, the other half isn't. Or one class in particular is not using it. Because sometimes it does make sense, actually, if you're working with a lot of data and you want it done now, you want to get rid of it, you might want to put a deallocate. dealloc in there. You might get rid of it. So it's never called. You can't ever call it directly. It's called automatically. But we do have a method actually inside of the class object called dealloc. You may have seen it in some of the templates. You may never have seen it if you've been pressing that button that says ARC on it. You'll never see it. So the life of the object, it does have a life cycle to it, as we've seen so far with the init. So your object should have an init method, which initializes all of the instance variables. If you see legacy code, it does have a dealloc method in it, so we don't need that. We don't need that if we're using automatic reference counting. But if we aren't, so we're doing it ourselves, that's going to clean up everything. What's that going to do? You're going to release. You're going to put a bunch of this release, that release, this release, that release, a bunch of releases that go inside of there. And the keyword is release, and you don't have to write a release method. You don't have to write a retain method. It's given for you automatically. So it's more in depth. We've actually covered the memory management a couple weeks back, actually. The naming conventions. So variables, which is kind of interesting because I see this like highly abused all the time as well. So variables start with lowercase letters and use capital A's to distinguish them. So they call it, lowercase t, capital A. Many different words. All we're just because you can't put spaces in there. But don't do this. This is a bad name with this underscores in it. Class names start with a prefix indicating that the project, could do it that way. Company or author to avoid name collisions. Example, SR scroller, project main view. I believe it or not, Xcode used to follow this. Now we have main controller or main view controller instead of everything named throughout the convention. So take this advice as kind of, you might use it, you might not use it kind of thing. Mutable string or text field. We're never going to. This is bad practice. Immutable string. You can't use reserved words as well either. All right, so that was our refresher, which was for those of you who came in a little bit late. That was number 6. It was lecture 6 from the downloaded materials. We had one example that was left over from last week that I want to kind of finish up with, and this one is called TextView. And we're going to go ahead and run through this tutorial. And it's simple. It's not too bad. It's not very entailed at all. And as we're running through it, I'm going to try to hopefully remember to point out all the different concepts I just went over, so you can sort of see it in terms of how it's implemented. And then, although I'm not going to sit and have you labor over writing the code. We're just going to cut and paste it. I still want you to kind of get an understanding of what it is you're doing. So this one here is located for those who did not download it or erased it from your desktop from last week. We downloaded it from, let's see, I believe it's going to be in the examples directory of object-oriented programming in C, and it's going to be in the source code examples. Is it going to be here? Yes, it is. It's this one right here. It's called TextView Project Tutorial. There's also a TextView Project Solution if you can't get it to work. Or if you don't have a computer right now and you want to see it later but you can't do it right now. That's going to be the solution right there for you. We went over already, I believe we did the reverse string, which was the category. I'm going to upload the finished tutorial. I have saved it. And we also did the toolbar and introspect last week. So just as a refresher, this is what we were doing, not last week but the week before. And I'm going to upload those solutions. I have them saved, actually. I didn't throw them away this time. But this one I do have a solution for. So. Alright, so here's how we're going to do. We're going to create a single view application. What we're going to work with here is a string that we're going to use as data that we're going to populate into a GUI component. And we're going to manipulate the string. And we're going to see how it works together in terms of the functionality of the data types and stuff. So here's how we're going to create. We're going to create a single view application. It's going to be a text view application. So the app's going to demonstrate the use of the app delegate as well, which we haven't really seen very much of yet. And the text view is added using a source code and not the interface builder. So what we're going to try and do is see how things are done programmatically instead of just dragging and dropping and putting a text view in there and stuff. So which is basically kind of the reason why you're trying to learn Objective-C programming, is so that you can create these objects. These are just objects you're creating. You don't have to use a GUI tool for it. And in some cases, this is actually the preferred method, because if you have a universal application where you have two GUIs. You have the iPad and the iPhone, and it's universal. Then you're going to drag and drop on, and you're going to actually manually create both GUIs using the interface builder, and then tie them both to one object component. Nah, just do it programmatically and add it to the view, whichever view happens to be there, which is a better kind of approach to doing it. So it saves you a little bit of work, makes it more generic in terms of the interface. So step number 1, create a single view application using the template. Name the project TextView. Select automatic reference counting, but do not select to use the storyboard feature. Okay, because we don't really need to complicate ourselves with that. So let's say I'm going to go in Xcode. Oh, I've got a lot of stuff in here. I'm going to create a new application. Single view application. And I'm going to call this one text. I'm going to call it my text because I already have one called TextView. My TextView. I'm going to make it for the iPhone just because I like that emulator better. And I'm going to use automatic reference counting. I'm not using storyboard. And I'm not using the option for a unit test as well. We're going to actually see unit tests coming up. Not today though, but it is on the menu showing up very soon actually. I just ran by that example myself the other day. And I went, oh, gotta show them this one. Alright, so now we have everything we've been doing so far. We have that XIB file, and if we click on it, it looks like that. And we're all set, ready to go. On step 2. Step 2. So we have it automatically created everything for us. Explore directory structure, check out the contents of the directory. Yeah, we did that. Expand the classes and notice interface builder created a view controller for us. We just saw that. Add the following code to the appdelegate.m file. Alright, so we're going to add something here, and we're going to put it in the application did finish loading. So, talking about the life cycle of the object today, just kind of explain a little bit more about what's going on here. The reason why we're in step number 1 and step number 2, we were supposed to notice that we do have this set of classes here. In the tab view controller example a few weeks ago, we changed the app delegate to load a different view controller. We took and we created a single view application. We added a tab view to it. We didn't remove the old one. We probably could have, but we have now had a brand new view controller. And now we can take that view controller. How are we going to let the project know what's going on with it? How do we know we're going to use it? Well, the app delegate is the section of the code that's going to tell us what we're doing, what we're going to load in here. For example, if we're going to load something after the view loads, like for our case it's going to be this text view, we're going to need to tell the app delegate to do it, otherwise it's not going to get loaded. So app delegate loads first, app delegate loads the view controller. So if you look at the app delegate code in the .h file, you see you've got UI window, that's our window, and then we have the view controller. And what are we looking at here? We're looking at instances of objects using property and synthesize, which if you remember from some of the previous examples, it's the same as if we just did this. I mean, we can say UI window, make an instance of UI window. If we do that, we have to do our own setters and getters. So we're taking and making it into a property so that we can synthesize it. And if we look at it over here on the M file, over here, we have, we're importing our view controller .h file by default. And we're going, well, how did that happen? Well, by default, when we made the project, we got a view controller.h, which is over here, which means we're going to implement the view controller.h to be this view controller. So we're making an instance of this object, view controller. We're calling it view controller. And then over in the app delegate, we're going to say view controller is going to be equal to, well, we just call it view controller over here. In the old days, it used to be called whatever the project was named, view controller. So if we look at the, so we have our two components. We have the window and the view controller. So we know right now, if you just, kind of just take a few minutes to kind of go, well, what's going on with app delegate? Well, app delegate is just basically holding up and responding to the life cycle of the object that we created, which is going to be this iOS application. We're actually importing the class, so it says @class view controller. So when we make other classes and we want to make instances of those classes from the app delegate, we use that @directive to say we're defining. This is a prototype for the class because we're going to use this class here if we put that in here without prototyping it, we haven't implemented it. It's kind of like using a function prototype or a method prototype and supplying the prototype before the implementation, because we haven't implemented it yet. It's not going to know what it is. If you leave that line out, it's going to go, what view controller are you talking about? So sometimes when you get those messages where you've included, over in the, over here, we've included the view controller file. We didn't include it over in the .h file. We included it in the .m file because we're going to implement it in the .m file over here. But over here we kind of made reference to it, so we use this @ directive to say we're making reference to it. Anyway, the UI responder is nothing more than a default inheritance mechanism for the life cycle. So if you imagine that this object has a life cycle, it gets instantiated when you click on the icon or touch the app. It gets loaded up into memory, and then we have this automatic behavior that occurs. I have a lecture, it's kind of long for today, but I'm not going to do it today. It goes through the life cycle of the object. It goes through all of did this view load? Did this happen? Did the application load? And we have all of the separation of all of those little life cycle methods that are separated out. Most of them are in the app delegate, long story short. So let's see, we have the window, we have the view controller, and we have the UI responder over here that's responding to, and it's following the protocol. We know there's a protocol, hopefully at this point, because we covered protocols, and we see, and every time you see this opening and closing, you're implementing a protocol. What is it? Well, it's going to be application delegate, which means we've created an application and we're going to run it. So if we go over here to the .m file, we see we have to implement from the protocol application. So we're defining our application over here in our definition of our application, and we're doing this inside of the app implementation for the app delegate, which is the .m file, including viewController.h, because we're going to use that view controller, and that's this guy out here. Or if we implement the protocol, and from the protocol UI application, which is we're going to make a new application here. So app delegate is really making our application instance, if you think about it, in terms of the subcomponents of this thread of execution that we're running here. We have an application. So app delegate's making it, and what's app delegate going to do? On the did finish launch with options, what are the options going to be? Well, whatever dictionary options we give it. Happens to be settings that are going to be sent to the app. It's kind of like the main, and you have those arguments that are passed to it to initialize an array from a command line old kind of concept. So what do we have? Self.window is going to be equal to, well, allocate a UI view, because we're an iPhone application. So we need a view, and then in it with the frame, well, the UI screen, main screen. And however we bound the screens. Well, how do we bind the screens? Well, that's going to be set. We can actually set this. We can actually open up the application with a small screen if we wanted to, with a big screen. We're going to let it automatically set. So, because we're not going to set the bounds. We're going to set bounds to the device. And then override the point of customization here after the application launch. This is where we can change and we can put some new stuff in here. I haven't pasted anything in here yet. This is the original code I'm going through, just to kind of show you what we're going to change. Because once I paste it in here, it's going to go away. So, self view controller allocate. So hopefully this stuff is starting to look a little familiar to you. And what are we going to do? We're going to initialize this. So we're going to run the initializer and init with nib name. And nib, as we talked about at the beginning of the course, is another form of XIB. It's the old way of saying interface. So it's an interface builder. What are we going to do? Or this is the name of the file. So if I were in any other class and I wanted to create another view controller and I wanted to load it up, I would do the same thing. So you can have, let's say, a button. You click on the button and it loads up different view controllers. And then what's it going to do? Well, it's going to auto-release the old ones. It's going to garbage collect it. That's when people like to retain. Because once you have one view, you have a button on the view that loads another view, and then you want to go back to the original view. Without a button, you need to retain that view, don't you? You're automatically going to have it garbage collected if you're using ARC. So that's a classic example when people turn off that ARC feature. Don't use it. Because you want to retain the view, because you want to flip back to it. Maybe you want to flip back to it, maybe not. Otherwise, you have to have a button that says, load the view again. depends on what's in the view as to how long the view is going to take to load. Sometimes you get better performance out of it. Or what if it's not going away? Maybe it's just a pop-up window. And I actually ran into this situation myself a few days ago, actually. It's just a little window. I want it to come up, show it, and then go away. Well, if it comes up and it goes away, the whole program was crashing. And I'm like, well, I have to manually retain that. The old view, because the new one is replacing the old one. It's on the same spot, same place in memory, and it's being garbage collected. So it's kind of weird. So anyway, long story short, we're loading this view controller, which is this file here. It's this view controller file here. And bundle, well, nil means it's good. I'm not going to bundle with anything. We're not going to send anything to it. What's a bundle? It's packaging through, it's actually the same words they use in, it's the same words they use actually in Android. It's the bundle, it's the data that you're going to pass back and forth between the views. Well, we're not going to pass anything here. In fact, if you're going to take any of the Android stuff that's coming up over the weekend, coming up soon, we will be working with bundles and hoping. And you'll see that this is the Cadillac way of doing it versus the Pinto way we're going to do on the Android system. It's a little bit more entailed. But so what we're going to do here, we're going to set the self window root view controller is going to be equal to self view controller. That looks pretty good. We're going to set the root control. This is going to be, again, another variable that says what's our root controller, which is our controlling device. And then self.window, make key invisible, just make it visible. That's the method that says make it available and show it and then return yes. Because it's going to come back. It's a Boolean method. It's going to pass or it's going to fail. If it fails anywhere, it's never going to return. So we don't have to worry about it not returning yes, because the whole program is going to crash down on us. If you ever have an application that doesn't run, it comes back and says application : and we're just going to say it's in the debug on the bottom of the window. It means because the application and the app delegate failed. Why is that? Because you renamed one of these files and it didn't match one of these files in here. Or it was looking for a piece of information, or it was looking for a component that you haven't added here. So if you ever run the application and your window comes up completely blank, probably because the app delegate hasn't loaded the right view controller, because you added a different view controller or something. So what do we want our app delegate to do? Well, we want it to load a TextView. So it's going to load a TextView in the window for us automatically. So I'm going to go back to our instructions here and now look at the code here. And we're going to add the following method to the app delegate.m file. And I'm going to cut and paste it out of here. And this is the application did finish launching. I noticed that I have it void here. Let's see. Copy. And it's a very old example. And I want to see, you don't necessarily need the rest of that code actually. I'm going to take a risk here. This one was Boolean, the other one's going to be void. Application, let's just add it underneath because it's a different method. I don't want to take that original one off. Let's see if I have a duplicate. I do not have a duplicate, which is good. Alright, so I was looking at the application, which is a Boolean, which is probably where I started my thinking already off target here. We have the application did finish launching, which we don't actually have in here, which is the question. I was trying to determine, in fact, I'm going to do this just to make this a little bit easier for me to read. During the life cycle of the application, we have a bunch of methods, and we don't actually need half of this stuff in here. Application will terminate, application to become active, application will enter foreground. We have all these comments in here. I'm not going to read the comments. You can read the comments on your own. We have all these various different application did this, application resign, which should hopefully tell you it's all part of the app life cycle. So the application itself is initialized in the first method that appears. You probably could safely remove the rest of this. And the method that we added is supplemental to all of that. And I'm going to get rid of this spacing here. The method that we ran, or that we added here, let me make sure I have a space actually here. Okay, I do. That's good. The method that we're running is after the application finished launching. It's kind of like the view did load. the view did load is not part of the app delegate, it's part of the view controller. It's the same equivalent method that says after we're done, after we've done everything else and the application's completed and we're loading, do something. Well, what are we going to do? We're going to add a UI view controller, navigation controller manually to this, and it's going to be, and we're going to allocate a navigation controller. And we're going to initialize it with the root controller. What's the root controller? What's the view controller? Which is our view controller from here. This is our view controller here. We didn't synthesize it. And we didn't synthesize it because we're going to take advantage of the auto-synthesize, as I mentioned before. If we don't synthesize, we put this little underscore in here. So you see legacy code that, okay, so there's a time in which we had to synthesize. And then there was a time in which the synthesizing was optional. And then there was a time in which it was done for you automatically. Now is the time you could just leave it out completely if you want. If you leave it out completely, you put the underscore in there. And we saw that actually was a couple weeks ago. We saw that, so I just wanted to make sure I pointed that out as well. We didn't run a synthesize on it. We don't actually have to on our properties. As long as we put this little underscore. We're going to do the same thing with window. Window, add the subview, the navigation controller, which is going to be the view. On the view, on the navigation controller. And then we're going to make it visible. So in here, basically all we're doing is essentially supplementing the window that we've already created, the UI window that we've already allocated, and we've already set the bounds, and we've already set the root view controller. Now we're just going to add the navigation controller to it. So we'll see how these pieces come together in terms of the example. So now we're going to create a variable for the next view, for the text view. So we're going to add a text view to the navigation view controller. Why do we need to? We have to add it to something, which is why we had to put the controller in there to begin with. So we could, in fact, so let me just point something out as well. You can drag and drop those controllers. All you do is come down here. I just typed in here. I'm gonna just type in control. I see view controller, tab view controller, collection controller. There's one in here that says navigation. Hit navigation controller. We added one manually by using the UI navigation controller. We just put one of those in there because we're going to do the whole thing programmatically. We're not going to drag and drop anything to the XIB file in this project because we want to see how we can use the source code to actually do it. Okay, so we added the controller. Now we're going to add a view to the controller. So we'll see how that works out. So we're going to create a variable for the text. Okay. And let's see what we're going to do. We're going to create a variable for the text view. And after creating or declaring the variable for the text view, we'll write a property for that. And then we will have to declare an object of that type, of the UI text view. So we're going to manually also declare a UI text view object. Call the text view, which will be connected to the label on the view. So make the following changes to the viewcontroller.h file. So we're going to go to viewcontroller.h. Not going to do anything with the XIB. We're going to look at the .h. And so what I'm going to do is kind of cut and paste this piece here because I'm a terrible typist. Or copy it, I should say. We're making an instance of TextView. The instance is, as I mentioned before, it's a UI, which is actually kind of interesting. So we had NS for next step. We have UI for user interface. It's a UI component. So the naming is actually kind of interesting. So I'm going to go into viewIcontroller.h, and I notice I've got the view controller is inherited from UI view controller. I just looked at inheritance, so I'm going to put my data in here because remember I'm right in the inside of that object, so I'm going to paste it in here. Because this is an object, I can property and synthesize it. I don't have to write my own methods to do it, but I still have to property it. So I'm going to go back over here because I don't like to cut and paste. I mean, I don't like to write. And see, I got the UI text view controller, text view. I'm going to do this too. I'm going to put the property line in there. Oops, if I can find my project again. Here it is. This just keeps me from having to write those setters and getters. And I don't have to synthesize it. Instead, over there, I can write this here. I can have, this is going to give me a message here, but I can use this. Well, I shouldn't press return. Oh, there we go. I can use this here with that underscore instead of synthesizing it. Or I can synthesize it and name it this. Or I can just synthesize it and use it by its full name. So that's what that, the synthesize is nothing more than creating the reference in the implementation. And the synthesize is actually what's creating the setters and the getters for us. So, which is kind of odd. Anyway, so I think I'm done with the .h file. So I'm going to remove all of the code in the .m file and then replace it with the following. So I'm just going to cut and paste this actually. So you can kind of see. I guess this is the easier way of doing this instead of piecemealing it, and then I'll go over. This is the last bit of the code, so I'm going to copy it, but I'm going to go over the code actually. Let's just take a look to see what's in the view controller .m file, which is nothing's going to be in there, so this is the easiest way of populating it. So if I go to the .m, I see I got a viewDidLoad method. That's going to be standard. And then I got a didMemory. Well, actually, I could take this one out completely and not have any problem at all. Don't really need that one. This one, I believe, actually, you know what, this method I think works actually with that one, without that one as well. Our implementation is pretty bare bone though, so I'm going to go ahead and get rid of everything in here, like my little instructions said to do. And I'm just going to paste the code in here, and then I'll fix my pasting errors in a few minutes. Oh, no pasting errors. Good. So I'll clean it up as I'm going through it so we can see what's going on here. Oh wow, my example has the interface and the end in it. I'm going to get rid of this here because I don't like this interface in the end, and we're not using it. It's completely empty, so I'm going to get rid of that. I've got my beginning here. I believe I'm going to have, we'll see what happens. When we get down there, I'll figure out what that error is all about. Alright. So as at implementation, view controller, that's good. Synthesize TextView, because we're going to use TextView. Remember, we didn't actually have to synthesize it, because we just used the underscore TextView. So now we have our new viewDidUnload, which is nothing. It's just, in fact, you could probably take it out if we wanted to. We don't really need it in there. Then we have another miscellaneous method in here. Should auto rotate to interface orientation. So we're setting an auto rotation here, which is kind of optional as well. We don't necessarily need that either. Actually, our default project didn't have that. I believe we're going to have some sort of auto rotation sets. Just make sure I don't have any extra spaces or anything in here. What is that going to do? Is we're going to return the orientation portrait upside down. It's going to handle our return call for when the physical device actually changes orientation. We can actually put code in there to do something, like pop up a message, for example, and say, hey, don't rotate me sideways. Or this way, it's just going to adjust our view to the new view. There's other ways of doing it automatically, however, as well. Okay, so now let's see what we got here. We got a set up the text view. We also got a method here that we did not implement over in the .h file, which is kind of interesting. I don't have that. I just have no setters, nothing implemented in there. So right now I'm questioning whether or not I actually copied everything in there correctly, but let's see. So now I have a self.textView, which is my text view. It's going to be equal to a UI text view alloc and init with the self view frame. And let's see why I have a message on that. I don't have a message on that. Okay, good. I believe I probably have some interesting characters in here that will come out. Let's see what this message actually says. Missing terminating character. Let's see. Expected at in the program. Okay. Let's go back here for a second. UI text to alloc. There's nothing wrong with that. Did I? Hold on one second. Let me just check real quick something. Okay, synthesized it correctly. UI text view delegate. Did I include that protocol? Probably not. So let me go back up here. And I can look at this in the .m file, excuse me, in the .h file, and go, that's what's missing. So I'm getting an error message, and I kind of started doing this on purpose to show you how these pieces fit together. Although that I did accidentally leave that out, actually. And I'm thinking to myself, well, if I were troubleshooting this, what would I do? It's having a problem with the UI text view. Can't allocate one. It's missing something. It doesn't know what it is. Well, I kind of changed this into a text view. I kind of changed it, the protocol. So I'm going to go back up here to the .h file and see, well, what did I forget to do? Well, I didn't include this here. So my line, I'm going to go like this, just because I don't want to type it. I'm going to copy it. I'm going to paste it over here into the app delegate, excuse me, into the viewcontroller.h file, right above where it currently is right now. And I'm going to compare the two here and look at this and go interface, viewcontroller. Yep, I left out the protocol. So I've got some I'm going to get rid of this side panel here. There we go. More real estate going on here. And then I'm going to say, well, I probably need to include the, oops, I probably misspelled it too. No, okay, good. No, I'm good. Okay, I don't need to include anything. I have that already. Actually, in the app delegate is including it. So now I'm properly implementing the UI text view delegate. This is the protocol file that we're abiding by, and we're making that implementation because one of the other things that kind of was a red flag to me is like I'm implementing methods that don't exist in my .h file. So what could that problem be all about? So where do these methods come from that I'm implementing? Well, they're coming from somewhere else or coming from a protocol. All right, so the protocol method has a setup text view in it, and the setup text view is where we kind of left off. We got through the first line. It looks pretty good. Let's see. Let me save the project, actually. Well, we were good for a minute there. Let's see. Let's just take another look here. Expected the at in the unexpected at. Missing terminating character. Alright, I'm going to chalk this up for a cut and paste error. I am going to chalk it up for a cut and paste error soon. Here's how I'm going to chalk it up for a cut and paste error. I'm going to take the finished one and copy the entire contents of that file and get rid of my cut and paste error so I don't have to worry about that right now. So I'm going to go back and it was the viewcontroller.m file. Actually, I'm going to compare it real quick actually before I start that. Yeah, the code is correct. So here's what we do. The finished sample, the finished product is actually underneath the tutorial as well. Unfortunately, I switched over. This is an older tutorial, and I switched over to a different format. This is a text file, not a PDF file. I switched to the PDF files because when I cut and paste off of the PDF files, it actually works correctly. This one here is picking up a bunch of strange characters, and I get a bunch of cut and paste errors from it. So, long story short, I'm going to take this whole thing. Oops. Yeah, I'm in the .m. Very good. Remove the contents of the .m. I'm just going to cut and paste it. Actually, this is the end of the project. I could have just opened up the other one, I guess, as well. But I do want to show you that this one works. And it does work. Okay, very good. All my cut and paste errors are now gone. Alright, so let's go back through and take a look at this then. So the setup text view is a method that does not occur in the viewcontroller.h file. It is in the protocol. And what we're doing here is we're implementing the UI text with alloc. We're allocating it. We're initializing it with our self for the view and our frame, which is going to be loaded from our view controller, which we always get well, from the app delegate gave us the view controller, and it gave us the window, and it gave us the frame that comes with it automatically from the view, because remember we put created a view as well. We're going to set the background color to black. We're going to set the font to Arial. We're going to set the app delegate to self, text app delegate to self, which means we're initializing it to be our current delegate or our current object state. The background color is going to be equal to white now, and for the text view that we're going to put in, so we're going to put a text view inside of, it looks like the text color is black, so it's black text on a white background. We put some initial code in here to set the text view text to equal, this is some sample text, yada yada. And then we're looking at the return key type, we're looking at the keyboard type, we're looking at scrolling. So if we were to actually put a text view on here, let me just show you something actually. I'm going to put this back. We do have a text view. Here's our text view. I'm going to stick it down here. Well, I'm going to put a little one on here. This is not the one we're going to look at. I'm going to stick this one on the bottom here actually. I'll leave it on here. Just going to stick it here because I want to show you something here. Over here in the properties for that text view that we have, here's all the text. We're going to take all this text back here. And we're going to put here lower text view. Oh, here, I'll just put lower on here. Where we have the set appearance, set return type, all of those attributes that we were setting for font here, set color to green, to font, to something, to bold. All of those things are those attributes that we're setting over here. So if I go back to the code, excuse me, that's what all this .font, .delegate, .background color, those are all coming from the properties. Nobody knows what all those properties are. You just look them up. But that's from the attribute, well, it used to be called the attribute inspector. It is from the attribute inspector from the XIB. So over here, if I click on this item, I get these are all the .textview, .this, textview, .that I'm setting in here for all of the different, here's the background here. So I can set the background to something. And that would be equivalent to setting the background in the code. Because we didn't put it on there, so we can't do it with our mouse like this. Instead, we're going to programmatically do it. Okay, so I'm going to go back to the .m file real quick here. So the return key type, actually I usually set it to done, but this is UI return key default. We don't necessarily have to set any of this stuff. We don't have to set any of this stuff actually. I could have just left half of this code out of here, and it would have worked just fine. Scrolling enabled, yes. Okay, so eventually down here on the bottom, auto resize, okay, so when we rotate it, it's going to auto resize it. I don't know why that rotation thing was in there, but it probably, to work with that. Add the subview. Subview is going to be self-text view. Okay, so then the view did load, which is our regular. So we normally start out with the view did load at the beginning of this file. We don't normally have this method. Don't normally have the auto rotation stuff in there either. That was all added. So super view did load. We'll run the super one as we've seen so far. So set the title to the text view title. No, it's not going to be a title. So we could put something in here like view, my view or something for our text view title. Set up the text view. Well, this is self setup text view. What is that going to do? That's going to run this method up here. Set up the text view. So we're going to run the method that we just created that's going to set up the text view for us. And then we're going to set it to nil, the text view to nil, which is going to initialize it to nothing initially. And the view will appear method. So now we're looking at some view did appear, view disappeared, keyboard show, keyboard doesn't show. All these different events that are going to occur throughout the life of this program can be automatically set to show or not show, or select or not select. And this is where we're seeing the selector stuff from again. So view will appear. Super view will appear animated. Well, it's going to animate the view. I don't know exactly what it's going to do for a text view. I can't remember at this point, but it probably just makes it show up all at once or something. NS notification center, set the default notification, add the observer, and then now you see where the syntax is coming into place. This is the Objective-C selector for the keyboard will show. We don't actually have to do this anymore. The keyboard shows for us automatically. So this again is legacy code. This is actually, this entire method's unnecessary. It's also going to set the notification for the keyboard will hide, keyboard will show, and you're going to notice it's not going to work because this is legacy. So now it's automatically controlled, and we have to look at the responders because the system's automatically making it appear when we type into the text field. we have to respond. We have to get rid of the first responder, which is going to be that text. The keyboard is going to show up. View did disappear, animating to disappear if the view goes out of view. I'm actually not even going to notice any of that stuff either. So it's just a bunch of extra stuff. Basically showing showing the view, unshowing the view. Keyboard will show notification to resize the keyboard. Keyboard will hide. That's the method that we're going to override to hide the keyboard. None of that stuff's really even necessary. Text view did begin editing. Okay, so if we did begin editing, what are we going to do? Well, we're going to save the information that's in the screen. So UI bar button item, save item. We're going to create a bar button item, and it's going to be UI bar button item alloc, and then because we have a navigation bar up there. In the navigation bar, we're going to put a bar button item, and the bar button item is going to be a save button, and the target's going to have an action for save action. And the save action is going to be down here, which is actually kind of funny because it's resigning the first responder. All that stuff with the keyboard, which is going to come up automatically for you now, but we're still going to resign it. So we're going to self.textView resign first responder to get rid of that keyboard that came up for us automatically. And then we're going to set the navigation item to the right bar button item to nil. Once we save it, it's going to go away. So when we type it in, we should see the button appear, because that action is going to happen when the text view did begin editing. So let's just run it actually, and we'll see what the behavior is going to be. I'm kind of concerned about this little message here. UI keyboard bounds, it's not going to matter actually. That is depreciated, it's not going to matter. Oops, I'm not going to run it on my iPad. Let me stop it. It's running on my iPad. Let me run it on an iPhone. I might have to get rid of that other little view controller if it's in the way. Build succeeded. That's a good sign. Let's see. This is also running on a 6.1 API version, which should not be a problem either. It is using some legacy code though, so we might. The other project as it's saved is saved in a 5 point something. And I don't see my navigation controller. So my button's not showing up. However, I am able to edit the text, however. So when I edited the text, the navigation controller should have popped up, but I didn't see the navigation controller to begin with. So I had a strange feeling. Let me see if I can degrade this, put this back down to a 4 point project type. Let's just check the project type out here actually. Let's mess around with it for a second here. Deployment target, we'll put it back down to a 5.0. iPhone, let's see. Save it. Is it still running? No. And I believe it's going to be our, let me take a look at our build settings. Let's go back. No, I don't have the build set to any of the lower libraries, so it's not going to matter. I don't believe I'm going to need to get that view controller to show up, and it's because the library is old. If you have an extremely old version of Xcode, this is actually in the 4 point something rather, before 5.0 came out. If you had an extremely old version, you would be able to see that navigation controller come out. Now I believe we could probably tweak it to work. So we're going to have the same response that's coming through. So I'm going to get, and even the keyboard stuff doesn't work either. So let's see, 1 second here. No. Alright, so I'm going to do one little tweak before I give up on it. Let me get rid of this guy down here. Navigation bar. Put the navigation bar up here. And the navigation bar button. Navigation item. Let's see. Well, actually, let's see if it works with the navigation bar. because it's missing the navigation bar. But I think I stick, let's see. We can add the item to it, and then what we could do is manually link the save button with the save code is what I was going to do, but I don't know if you guys know how to do that. So the way you can resolve this to upgrade it, we're going to get the navigation. No, yeah, we don't have the navigation bar on this one either. We have the interesting. Well, we have it taking up. We have the view actually covering up the navigation controller, which is kind of another interesting issue. And we also have a different size. No, it doesn't matter. Interesting. Okay, well, it has a few bugs in it. The bugs in it are due to the fact that the libraries are sort of old, and the navigation techniques have changed in the current API. So. But you can manually move the view. You'd have to resize the view so it didn't take up the entire window, but the text view took up a smaller portion of the window, put the navigation bar above it, add a button to the navigation bar, and link that one to the save file. But you see the text view is loading, which is a good sign. It's just that this navigation bar is going to be the issue. So. That and the whole keyboard behavior is going to be an issue. Even though the code's in there, it's still not working. It's not going to work. So. Alright, well that was the text view example for today, and which was actually left over from last time. The other one that was left over from the 2 times before was the DatePicker, which is not a bad project. Again, it doesn't have a finished solution, but it's actually a very simple one that merits some looking at. Remember the project that we did where we created a date, and we had the date, and we actually did a stopwatch with it with a timer. This is essentially demonstrating the picker. I'm going to try to open it with preview. Can't open it. I don't have a preview option here, do I? Let's see if I can open it with preview so I don't have to worry about cutting and pasting. I'll open it with Text Wrangler. Let's see what happens. Oh, it's not too bad. I can write this code. Actually, it's not too bad. I just don't want to go through that cutting and pasting again. So let me make this view a little bit bigger, at least so you can see what I'm looking at. This one here is also, it's called the DatePicker. It is the one that was left over. So today we're playing catch up from the day that we did the time. So it's going to be in the same location, so that you can go ahead and download this example. It's going to be in the source code examples. Towards the top, where we have, supposed to be in here, using data type tutorial, digital clock tutorial. I don't have it in here, so I will put it in here. It's either that or it's going to be in the other one. Let's see, hold on. I had some of these in multiple locations. It's an iOS application. Somebody on the internet? Let's see, example projects. Okay, it's left out. I have to put it up there. So you can at least follow along now and see what this is doing. It's actually kind of simple. You may not even need the finished solution for this. I thought I had made this bigger. Let's see, hold on. Let's see. There we go. It's a little bit bigger. Alright, this one's actually quite simple. It's not too bad at all. It's again, I'm going to demonstrate the DatePicker, which is going to be a way of getting from the GUI control setting. It's very similar to what we did with the timer and the stopwatch that we did in the digital clock, except for we're going to be using it to select the date from a GUI component instead. So this example, we're going to use the UI DatePicker and add a UI picker to the subview that we're going to be working with. So create a single view application and call it DatePicker. So this one is not finished yet, so I'm going to go ahead and save this one then when I do it. So this one's going to be called DatePicker. So single view application. And I'm going to call it DatePicker. Let's see if we want to use the storyboard. Let's see. Where did my, let's set some text view. There we go. Nope, this one's not going to create it. I need to revise this one so it has a little bit more instructions on it. I'm not going to use a storyboard. I'm just going to use a single view application with a single XIB file. So let me finish creating it. So I'm not going to select storyboard. I'm going to do it for iPhone actually. So next. And then it is saved now on my desktop. So now I'm going to open up the project and click on the XIB file. And then come over to the lower right hand library here and select, let's see, if I put in date, I get DatePicker. Not too bad. So I'm going to put DatePicker. I'm going to drag a DatePicker over and stick it on the canvas there. And it's on today. And it's 4:39. Oh, look at that. That's the right time, too. The date and time picker. All right. So drag a DatePicker object over from the library, place it into the view controller to XIB. Wire it as a property to the view controller. And tell me what I want to wire it as. Let me just see what the name is going to be called here. I'll call it my DatePicker. How's that? We'll just have to change it in the code. So I'll be DatePicker. We'll call it DatePicker because it's called DatePicker here. So go ahead and wire it. So we're going to go back to the Xcode project. I'm going to click on the little tuxedo icon here to get my code up. I'm going to get rid of the side piece here. I'm going to click on the DatePicker, press the control button, and wire it over here. And I'm going to call it DatePicker with a lowercase d, and press continue. So now it's a UI DatePicker, and it is called DatePicker. So I can synthesize it over here by clicking on the .m file, and right underneath the, let me get rid of this implementation, this interface here. Right under implementation, I can go ahead synthesize, and then put in DatePicker. I'm hoping at this point you guys are very comfortable with this, what I've been doing so far, because this is basically the same steps we've been doing over and over again for like the last 6 or 7 weeks. So, okay, good. For those people who are following along, that is. Alright, so we're going to change the view did load to what, bring up today's date or something? Actually, I think it already does that. So we can pick another date if we want to. So in the view did load of the viewController.m, create a new, we're going to create a new NSDate object. And the NSDate object is created in a way that is going to hold the current date and time. We will then set the DatePicker to that date, which ensures every time that the view loads that the DatePicker will reset to the current date and time. So I'm going to it's just 2 lines of code here actually. I'm just going to copy this one here and hope that I don't get any special characters when I paste it in. So in the view did load, let's see. I'm going to put it underneath the super view did load, and here's what I'm typing in for those people who don't have this to cut and paste in. We are going NSDate now, calling it now. It's going to be equal to NSDate alloc init. So we're initializing a new NSDate. So it's just like saying NSString. These are the 2 lines of code I just pasted in for those of you who are typing it. DatePicker set date :now. Now is the state here, so it's taking a date format, animate yes, which means it's going to do that little thing, Ferris wheel thing. So now if we run it, actually it should set the date. It would kind of be interesting to see if it would actually set the date anyway, because when we dragged it over, that was the first time I noticed actually that it sets the dates. But I think it's just because it's in the project. I wonder if we saved the project, would it be set on today's date tomorrow? I don't know, it's an interesting question. Oops, I'm running it on the iPad. Hold on one second. Let me take it off the iPad. Sorry, let me actually disconnect. Well, I won't disconnect. I'll just remember to switch back over. And for those of you who have an iOS device and don't have it set up yet, let me know. I can set it up. We did that a couple weeks ago. Yeah. Alright, so now I have my device plugged in there because I'm actually charging it. Well, it's actually for the tic-tac-toe game we're going to do next as well. So, to show you some interesting thing with it. Oh, so today is set, is it set? Okay, good. So it does work. You know what's interesting though? I know I have a few minutes today. Let's see this. Just want to see something. I just want to see what would happen if we didn't set it to today's date. Would it automatically set to today's date? Does it? Well, we don't have to set it to today's date. We can set it to another date if we want. Then we have to worry about setting the parameter correctly. So let's see. Today, 4:40. It is setting it to today's date. Well, let's assume it's not setting it automatically to today's date. And we're just going to set it to today's date. It gave some people time to catch up who were typing that code in manually anyway. So, alright, so now we're going to drag a round rectangular button from the library and put it over on the window. We're going to wire the IB outlet. Touchdown event, and we're going to call it button pressed. What's this button going to do? The button is going to change the date. Oh, it's just going to tell us what it is. Alright, so let's wire a button. So I'm going to click on the side panel over here, take a round rectangular button. Drag it over here. I'll just leave it called the button. Put the button right here. I'm going to right mouse click on the button, take the touchdown event or touch up inside. Here, I have the touch up inside. Wire it to, and then I've noticed over here I have the .m showing, so I'm going to toggle that back to the .h. I'm going to wire it underneath the other property that I have, so touch up inside. Pressing down on the control button, and this is going to be button pressed. And I'm going to change the ID type to UI button because I like to do that. You can leave it on ID, it works the same way for our purposes. Knowing that ID is just a generic type for the object. Alright, so I have button pressed, so I've gotten that far. And now here's the implementation that we've got down here. We've got the IB action button press that was put in there. Okay, so we're going to add the viewcontroller.m to add the following code to the button pressed method. So I'm just going to, it's going to send up an alert actually, what it's going to do. So let's see, this is again, you know, kind of an older example that we didn't cover that one day, so we're way ahead of this. This is going to seem way too easy for us. Our button pressed is going to take the time from the other objects and put it in an alert box is what it's going to do. So I've gone to the .m file, and for those of you who are going to copy this from my screen, I'll leave it up here for a few minutes so you can see what I'm typing. So in my button press method, I'm creating an NS date from the selected date from the picker. So we can change the date on the picker actually. So it's going to come up with our today's date, we'll change the date on the picker, and then we'll press the button and the button will show us the date we picked, which is essentially just demonstrating the use of the data from the object. So we're going to create, instead of in this view did load, we created now by allocating a new instance of date and initializing it and sending it to the now object, which is a data type NS date. But now we're just going to do selected. So it's going to go to the date picker and retrieve the date. It's kind of like get date, set date. So from date picker, we've automatically property and synthesized it, so we have a date. It's going to return the date that the date picker is actually set on. Now that's going to be equal to selected. So then we're going to create a string here, and string is going to be a message that we're going to put out to the screen. And the string, NSString message, is going to be equal to new NSString alloc, and then in it with the format. What's the format going to be? Well, we're going to put an @ symbol, and in the @ symbol, we're going to say the date and the time you selected is : and then if anyone remembers from like printf, from like C code, well, this is they used to call it a there's two bits of pieces of information in here. We've got this percent, what is it, the percent, is it, yeah, it's the percent sign followed by a data type. This data type is the A for the object, which is the @ directive, which is the generic type. So, and then this comma here after, so we have this basically, when I said printf, it's kind of like printf where we put in C, this is legacy C syntax. It's incorporated into C++ as well as Objective-C, but you put a string text in, you put a placeholder for an item of a variable that you're going to put in here, and you're going to insert this in here, and you're going to use the % sign as a directive, excuse me, a % sign as a placeholder with an @ directive to say, because what we're including is coming in after the comma selected. Selected is selected. It's of an object type, which is how we can use the @ symbol. If this, let's say for example, were a decimal, we'd put a D in here. It's not, or an F for a float, an I for an integer. In Objective-C, we have @ symbol for the object type, which is just the generic, and it's comma selected. Selected is essentially the variable that we're going to put in. It's the object variable of the date. So we're going to print that out to the screen in the alert. And here's our UI alert. So we're going to make a new instance of a UI alert. And in this particular example that you're looking at, I see 1, 2, 3, 4, 5 different objects that we've created. It's going back to the object-oriented programming concept. All we're doing is create instances of objects. These are all instances of objects. This is an object, date's an object, the now date's an object, the string's an object, the UI alert view is an object, everything's an object. All done the same way. So in here we have our UI alerts, and here's our alert. It's going to be equal to allocate a new UI alert. So I said just memorize this code, because after you've done this at least 2 or 3 times, it's like there's no way you can forget it anyway. In it with title, the title's going to be date and time selected, and the message. So we see these are kind of, and then going back to what I was saying earlier about, you know, how it's easier if you have the named parameters. It's easier to figure out which parameter is supposed to go for which one of the placeholders. So in here we have, you know, the message : message. Well, that's this message up here. That's this object. And then a delegate's nil, which means we're not going to assign anything. Cancel button. We're going to put a cancel button on there. That's going to be : yes, I did. I don't know why. Yes, I did. But another button, nil, which means we're not going to put another button on there. We're calling this alert. So if we're going to create this alert object and put these other objects inside of it, which we're doing here, then we have to show it. So alert.show, or excuse me, alert space show, basically says run the show method on alerts. And so what we're going to end up happening is this little alert button is going to come up after we've set the DatePicker to do something. So now if we run it, and I have it set on DatePicker, unless we have some depreciated library or some functionality that doesn't work anymore, we should hopefully have a DatePicker that shows up with a button. And let's see, it's right here. Let's go. Oh, there it is. It's back there. Should show it with today's date, which it does. And so if I change it to February 27th at 5:54 p.m. It's February 5:54. So if I click this button that says date and time selected, the date and time you selected is the 28th. 13:28, or maybe I selected oh, it's in the morning, I guess. PM? PM? No. It's off by day. This is a 2:28. Yes, I did. No, I didn't. This is 2:28. This is going to say 2:29. No, it's going to say 3:1. There's no 20. There's not. Wait a minute. There's a February only has 28 days. Okay, so let's see if it gets March correct. No, March 2nd. It's off by day. You know what, though? I have this time zone set incorrectly. I haven't set the time zone. The time zone is a default variable that you're setting on the emulator, which we haven't set yet. It's probably on Eastern time zone. Or no. This was made by Apple. It should be California, Pacific time.
Might be GMT.
Might be GMT. Actually, it says plus something next to it, so yeah. Looks like GMT time. So if we set the time zone correctly, then we may actually get the correct time coming out of the DatePicker, I believe. But again, I believe that's probably our problem with that one. So anyway, this one was an old example we hadn't finished yet. This was about 2 or 3 weeks ago, and back when we were looking at the digital clock. So if you don't like the digital clock component, we can create the, this is not really a clock. One of the assignments for this class has you use a DatePicker, I believe, or used to have you use a DatePicker to do something in terms of one of the interfaces. I think actually this one does. The digital clock assignment has you use a DatePicker, so for one of the things, I don't know, for the time and date. All right, and I compile and run, and then we're done. which is good. So we are actually now up to date. The other lecture we didn't do, I still have time for it because it's only like 5 slides long. Nope, that's not that one. Not that one. That's 41 slides long. Was, let me find the right one. We did we didn't do number 7. This one's too long as well. I had a little one. Let me just see. I thought it was number 5. 41 slides. Not good. No. I think it was number 6. Yep. That's the one we did. Okay. Well, we're going to have a... You guys want a break, or do you want to start in on another project? I'll leave it up to you guys. I thought I had another little mini, like a half-hour lecture. Otherwise, or I can end early today, one or the other. We're going to build 2 major projects in the iOS class. So maybe it is a good idea to take a break. Alright, we'll take a break. We'll end a little bit. You guys have a break. We'll end up a little bit earlier today.